Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic today, trigonometry. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to understand and use the basic trigonometric ratios. You should be able to understand and use the Pythagoras theorem. And you should be able to solve practical problems that require the use of the trigonometric ratios and the Pythagoras theorem. So, our studies on trigonometry will be mainly centered on the trigonometric ratios and the Pythagoras theorem. We are going to begin with the trigonometric ratios. What are the trigonometric ratios? The three trig ratios are sine, which has the short form sin and is pronounced sine, cosine, which has the short form cos and is pronounced cos, and tangent, which has the short form tan and is pronounced tan. These are the three trigonometric ratios. So I said trig. Trig is the short form of trigonometry. So whenever you hear me use the word trig, I mean trigonometry. So the three trig ratios are sine, cos, and tan. To find them for any acute angle in a right-angled triangle, first identify the sides of the triangle. The sides of the triangle are 1. Hypotenuse. The hypotenuse is the longest side or the side opposite to the right angle. 2. Opposite. Opposite is the side opposite to the angle under consideration. And 3. Adjacent. Adjacent is the side next to the angle under consideration. What does this even mean? Let's find out. Let's consider this right-angled triangle. So we have this point here as point A, this point here as point B, and this point here as point C. And together they form this right-angled triangle. We know it's a right-angled triangle because we can see this sign. This sign is the right-angled sign, meaning that the angle formed here is 90 degrees. We know that a triangle that has one of its interior angles as 90 degrees is a right-angled triangle. Now you see that if this side here is 90 degrees, these two angles here, I mean the angle at angle C, the angle that will be created at point C, and the angle that will be created at point A, these two angles will be acute angles. In the video on angles, we learned that acute angles are angles that are less than 90 degrees. So these two angles will be acute angles. These two acute angles, we can find them using the trigonometric ratios. So if we know the length of the sides of this triangle, we can use the trigonometric ratios or the trig ratios to find the acute angles, the value of these angles. In the same way, if we know the value of these angles, we can use the trigonometric ratios or the trig ratios to find the length of the sides of this right-angled triangle. So these are the two main things that we will be using the trigonometric ratios to do. The trigonometric ratios that we've learned right now, which are cos, sine, and tan. We will be using them to find the value of acute angles in a right-angled triangle or the length of the sides of a right-angled triangle. Now that is what the point was telling us, that in order to find the value of the acute angles or the length of the sides of the right-angled triangle, we need to know these three sides of the right-angled triangle. The first one is the hypotenuse. In a right angle triangle, the hypotenuse is the longest side or the side opposite to the right angle. Opposite is the side opposite to the angle under consideration, and adjacent is the side next to the angle under consideration. How do we find these three trig ratios for this right angle here? Let's say that we call the length of AB, that is the distance between A and B, we call that X. The distance between B and C, we call that Y. And the distance between A and C, or from A to C, we call that H. The hypotenuse is the longest side of the right angle triangle. So clearly you can see that the longest side is AC. So that is the hypotenuse. Now we are going to call this angle here angle theta. This acute angle here, we are going to call it angle theta. In relation to the angle theta, line AC, or this time the distance H, is the hypotenuse, because moving from A to C, that is the longest side. Remember the point said the hypotenuse is the longest side or the side facing the right angle. This is the right angle, so the side facing the right angle, as we can see here, is the hypotenuse. So always in a right angle triangle, the hypotenuse is the longest side or the side facing the right angle. So in this right angle triangle, AC is the hypotenuse. Considering this angle here, angle theta, the length BC, that is from B to C, which is represented by Y, the length BC is the opposite, because BC is opposite to this angle here, which is theta. So BC is the opposite side because BC is opposite to theta. I hope you are clear. BC is the side opposite to the angle we are considering. The angle we are considering in this right angle triangle is theta, this acute angle. So BC is opposite to theta. Then the other remaining side is the adjacent. So here AB is the adjacent side. So considering this angle theta, AC is the hypotenuse, BC is the opposite side, and AB is the adjacent side. How do we use the trig ratios to find the value of this angle here, angle theta? We are going to take the trig ratios one after the other. So here we know that here is theta, this side X is our adjacent, this is opposite, and this is hypotenuse. We are going to take the first one, which is sine. So we are saying that sine of this angle here, so sine theta. Sine of theta is equal to the length of the opposite side. The opposite side is Y, divided by the length of the hypotenuse. The hypotenuse is H. So if you take a right angle triangle, sine of an acute angle in the right angle triangle is equal to the length of the opposite side over the length of the hypotenuse. So here the opposite side is Y, the hypotenuse is H. So sine of theta is equal to Y over H. With this, we can find theta. We will learn how to do that. The next one we are going to consider is the next trig ratio, which is cos. Cos of theta, or cos of an acute angle in a right angle triangle, is equal to length of the adjacent side. In this diagram, the adjacent side is X if you are considering this angle theta. So adjacent to theta is X, divided by length of the hypotenuse. The hypotenuse is H. So we have X divided by H. Then tan, which is the last one, tan of this angle, so tan theta is equal to opposite divided by adjacent. So the length of the opposite side, which is BC. BC is opposite to theta. Remember, we are considering everything in relation to theta. So BC is opposite to theta, AB is adjacent to theta. So it's opposite, which is BC or Y, divided by adjacent, which is AB or X. So tan theta from this diagram is equal to y divided by x. To help us remember all these things, we use these mnemonics. So, ka, twa. I don't know if you've heard of this before, but this mnemonic is going to help you to remember these three ratios. So is for sine. It means that sine of an angle, or sine theta, is equal to opposite over hypotenuse. So when you see so, it means sine is equal to opposite over hypotenuse. Ka is for cos. It means when you see cos is adjacent over hypotenuse. So A is adjacent, H is hypotenuse. So it means that cos theta is equal to adjacent over hypotenuse. The last one is twa. It means tan. So tan theta is equal to opposite, which is O, divided by adjacent, which is A. So if you remember these mnemonics, so, ka, twa, you'll be able to remember these three trig ratios. Thank you for watching this video. Don't forget to like and subscribe. In the next video, we are going to solve questions using the trig ratios that we've learned in this video. Bye-bye. We are on the topic trigonometry. In the previous video, we learned about the three trigonometric ratios: sine, cos, and tan. In this video, we are going to learn how to use these trig ratios to find the value of the acute angles in a right-angled triangle. Let's take some questions and see how to do that. Find the angle theta in the diagram below. So we have this diagram and we are supposed to find the value of theta. This is the angle theta that has been given to us. So we are going to find the value of theta, and you will use one of the trig ratios. In the previous video, we learned that considering this angle theta, this side here, which has 4 here, meaning that the length of this side is 4. This side is opposite to theta, and this side is the hypotenuse because it is the longest side. Looking at the diagram, you can see that that is the longest side, or is the side facing the 90 degrees. So this side here is the hypotenuse. So here is the hypotenuse, and here is opposite. So we are looking for theta. We have opposite, we have hypotenuse. So which trig ratio should we use? Remember the mnemonics. So, ka, twa. So, ka, twa. Meaning that we should use sine if we have opposite and hypotenuse. We should use cos if we have adjacent and hypotenuse. And we should use tan if we have opposite and adjacent. Here we have opposite and hypotenuse. So we are going to use the first one, which is sine. So sine theta, sine of this angle, which is theta, is equal to the opposite to theta, which is 4, divided by the hypotenuse, which is 7. So the opposite to theta is 4, the hypotenuse is 7. So we have sine theta is equal to 4 over 7. How do we find theta from here? You have to find the sine inverse. To find theta, we need to find the sine inverse of 4 over 7, or 4 divided by 7. This is what I mean. Theta is equal to sine inverse of 4 divided by 7. So you write sine inverse, then 4 divided by 7. How do we calculate for the sine inverse of 4 divided by 7? You are going to find that with our calculator. So you switch on your calculator. Then you press on shift. Then you press on sine. So you see, as soon as you press shift sine, the calculator will write sine inverse and open a bracket. You click on this fraction button, then you enter the fraction in there. The fraction is 4 divided by 7. After you've done that, close the bracket and press equal to. Now when you press equal to, the calculator will calculate sine inverse of 4 divided by 7 for you, and that is 34.849. The numbers go on and on. I'm going to run my answers to one decimal place. So theta will give us 34.8. Don't forget that theta is an angle, so the unit is degrees. So theta is equal to 34.8 degrees. So you see that using this trig ratio, we have been able to find the value of this angle here to be 34.8 degrees. Let's pick the next question. Find the angle theta in the diagram below. So considering this diagram, we can see that 5 is the hypotenuse because it's the longest side, or the side facing the 90 degrees. 3 is the adjacent side. 3 is adjacent to theta. So here we have adjacent, we have hypotenuse. Once again, don't forget SOHCAHTOA. So SOHCAHTOA. Meaning that if we have adjacent and hypotenuse, we should use CA, which is cos. So here we are going to use cos. So cos of this angle, which is theta, cos theta is equal to the adjacent, which is 3, then hypotenuse, which is 5. So it means that theta is equal to, you find the cos inverse of 3 over 5. So cos inverse of 3 over 5. Just as we did when we were finding sine inverse, you are going to do the same thing with cos inverse. So here, you switch on your calculator, you press on shift, you press on cos to get cos inverse. Then you enter the fraction. 3 divided by 5, you close the bracket, equal to. So the calculator will compute the value of cos inverse of 3 over 5 for you, which is 53.130. So running it to one decimal place, you have 53.1 degrees. So you see that with this trig ratio also, you have been able to find the value of this acute angle in this right angle triangle to be 53.1 degrees. Thank you for watching this video. Don't forget to like and subscribe. In the next video, we are going to learn how to use trig ratios to find the interior acute angles of a right-angled triangle, just as we have done in this video. We are going to solve more questions using the trig ratios. Bye-bye. We are on the topic trigonometry. In the previous video, we learned how to use the trigonometric ratios to find the interior angles of a right-angled triangle. In this video, we are going to solve 3 more questions on finding the interior angles of a right-angled triangle. Let's pick the first question. Find the angle theta in the diagram below. So in this diagram, we have our angle theta here. So this is the acute angle that we are going to find its value. Considering theta, we will see that this side here is opposite to theta, and this side here is the hypotenuse. So this side is opposite, this side is the hypotenuse. So in this diagram, we have opposite and we have hypotenuse. Which one of the 3 trig ratios should we use? If you have opposite and hypotenuse, we are going to use sine. So it means that sine theta is equal to the side which is opposite, which is 5, divided by the hypotenuse, which is 11. So sine theta is equal to 5, which is opposite, divided by the hypotenuse, which is 11. So sine theta is equal to 5 over 11. Theta is equal to, you find sine inverse of 5 divided by 11. So sine inverse of 5 divided by 11. In the previous video, we learned how to find sine inverse and cos inverse. Let's do that once again. So you switch on your calculator, you press on shift, we are looking for sine inverse, so you press on sine, then you enter the fraction that has been given to you. So 5 divided by 11, close the brackets, and the calculator will compute that for you. So we have 27.035. The number continues on and on. I'm running the answer to one decimal place, so I'm going to have theta is equal to 27.0 degrees or 27 degrees. So the value of this angle here, if the hypotenuse is 11 and the opposite side is 5, is 27 degrees. Let's consider the next question. We have theta here. This side is opposite, so the opposite side is 5. This side is the adjacent side because here is the hypotenuse. Here is the longest side. So the longest side, or the side facing the 90 degrees. So here is the hypotenuse. We don't know the value for the hypotenuse, but we know that this side is opposite. We know that value to be 5. And this other side here is the adjacent side, and we know that value to be 2. Now here's a trick. When you have the question and you don't know the hypotenuse, it means that you are going to use tan, because tan is the only trig ratio that doesn't contain the hypotenuse. So we are going to use TOA, which is tan. And tan is opposite divided by adjacent. Remember the mnemonic TOA, T-O-A. So it means that tan is opposite divided by adjacent. So opposite divided by adjacent. Tan theta is equal to the opposite side, which is 5, divided by the adjacent side, which is 2. So from here, you will find theta as tan inverse of 5 divided by 2. So switch on your calculator, shift tan, then 5 divided by 2. Don't forget to close the brackets after that. So that will give us 68.1985. If you are running this to one decimal place, you are going to have 68.2 degrees. 68.2 degrees. So theta here is equal to 68.2 degrees. Let's look at the last question for this video. We have theta here as this acute angle. So 11 is opposite to it, 13 is adjacent, because this side here is the hypotenuse. We don't know the value of the length of the hypotenuse. Okay, so we have opposite, we have adjacent. We don't know the hypotenuse. It means that we are going to use tan. Tan theta is equal to opposite, which is 11, divided by the adjacent, which is 13. So theta is equal to tan inverse of 11 divided by 13. And 11 divided by 13, so it's tan inverse of 11 divided by 13. So shift, then tan, you enter 11 divided by 13. Then you press on equal to, and that will give us 40.236. So if you are running this to one decimal place, we have theta to be equal to 40.2 degrees. So we see that with these trig ratios, we have been able to find the interior angles of a right-angled triangle. So the acute angles in the right-angled triangle, we can use these trig ratios to find them. Thank you for watching this video. I hope you enjoyed it. Don't forget to like and subscribe to this channel for more videos. In the next video, We are going to learn how to use the trig ratios to find the length of the side of a right-angled triangle. So this time, we will not be finding the angles. The value of the angles will be given to us. So we will use that value to find the adjacent side, the opposite side, or the length of the hypotenuse. Bye-bye. We are on the topic trigonometry. In the previous video, we learned how to use the trigonometric ratios to find the acute angles in a right-angled triangle. In this video, we are going to learn how to use the trigonometric ratios to find the length of the side of a right-angled triangle. Let's pick the question for this video. Triangle ABC is a right-angled triangle. Find the length of AB and the length of BC. So this is the triangle given to us, and the question says it's a right-angled triangle, and we can clearly see it. We have been given an interior angle here. We already know that this is the right angle, so that one is 90 degrees. We already know that. But we have also been given another interior angle here to be 60 degrees. We have also been given another interior angle here to be 60 degrees. We have been given this side as 7 centimeters, and we are supposed to find the length of this side, which is AB, and the length of this side, which is BC. Now, how are we going to do this? This is how we are going to go about it. We are going to use these two information that have been given to us to find the length of AB and BC. That is, we are going to use this interior angle that has been given to us and the length of this side here that has been given to us to find AB and BC. Let's first start with AB. So we know that if we are considering this angle here, which is 60 degrees, this length AC, which is giving us 7 centimeters, is the adjacent. If you are considering AC, then this side here, which is, if you are considering 60 degrees, then AC is the adjacent. AB is opposite to 60 degrees, and this side here is the hypotenuse. Okay, so we know this. Considering 60 degrees, AB is opposite, AC is adjacent. The adjacent is 7 centimeters. We are looking for the opposite side. We know that if you have opposite and adjacent, the trig ratio you have to use is tan. Remember that we are concentrating on AB. From there, we will come to BC. So let's concentrate on AB for now. So considering 60 degrees, AB is opposite, AC is adjacent. So we know that if we take tan of this angle here is equal to the opposite side divided by the adjacent side. So we can see that from the diagram, tan of this angle here, which is 60 degrees, so tan 60 degrees is equal to the opposite side, so AB, the length of AB, divided by the adjacent to the adjacent side, which is AC. So tan 60 is equal to opposite, which is AB, divided by adjacent, which is AC. We know this from our studies on the trig ratios. We know AC to be 7 centimeters, so we have it here, 7. So tan 60 degrees is equal to AB divided by 7. So all we need to do now is to make AB the subject. So you multiply the left-hand side here by 7. You multiply the right-hand side here by 7. Now when we do that, you can see that this 7 here will cancel this 7 here. So we will say that the length AB is equal to 7 times tan 60. But tan 60 is square root of 3. How do we know this? You punch it on your calculator. So you switch on your calculator, you press tan What do we want? We want tan 60. So you press 60 and then you close the bracket. And that we have square root of 3. So 7 times tan 60 is the same as 7 times square root of 3 because tan 60 is square root of 3. So we have to look for 7 times square root of 3. So 7 times square root of 3 will give us, this is giving us in third form. If you watch the video on third, we said that if you click on this button, the S to D button, it will change it from third form to decimals. So we have 12.124. The number goes on and on. I'll leave my answer to 2 decimal places. So we have AB is equal to 12.12. Don't forget the units centimeters. So the length of AB is 12.12 centimeters. Let's go on to the second part, which is finding the length of BC. Finding the length of BC. We are still considering this angle here, which is 60 degrees. Considering 60 degrees, we said that AC is adjacent and BC is the hypotenuse. So we have adjacent, we have hypotenuse. So what trig ratio should we use? Cos. Cos 60 degrees is equal to adjacent. The adjacent is AC, which is 7 centimeters, divided by the hypotenuse, which is BC. That is what we are looking for. Okay, so I'll multiply the left hand side by BC. I'll multiply the right hand side by BC. So this BC and this BC will cancel. So you have BC times cos 60. So you find cos 60 on your calculator. So you press on cos, then you press on 60. You close the bracket, and that will give us 1 over 2. So cos 60 is 1 over 2. This is going to give us BC times 1 is BC, so BC divided by 2. You multiply the left hand side by 2, the right hand side by 2. 2 will cancel 2. 7 times 2 will give us 14. So it means that the length of BC is equal to 14 centimeters. So you see, using the trig ratios we have been able to find the length of the side of a right angled triangle when a side and an interior acute angle is given to you. So here we are given the side AC and one of the acute angles are 60 degrees, and we have been able to find the opposite angle, the opposite side, and the hypotenuse. Thank you for watching this video. In the next video, we are going to solve more questions on finding the length of the side of a right-angled triangle using the trig ratios. Bye-bye. We are on the topic trigonometry. In the previous video, we learned how to use the trig ratios to find the length of the sides of a right-angled triangle. In this video, we are going to solve another question on using the trigonometric ratios to find the length of the sides of a right-angled triangle. So let's look at our question for this video. Find the length of PQ and PR in the right-angled triangle shown below. So we have the right-angled triangle PQR. This side is 10 centimeters and this interior angle is 45 degrees. This is the right angle. So it means that the side facing it is the hypotenuse. So here QR, which has the length 10 centimeters, is the hypotenuse. We are looking for PQ and PR. We are going to find PQ. After that, we will find PR. Considering this 45 degrees angle, we can see that PR is opposite to 45 degrees. So we have opposite PR. That is what we are looking for. We already know the hypotenuse. So we have opposite, we know hypotenuse, and we know this angle as 45 degrees. We can use this information to find PR. So PR is opposite. This side is hypotenuse. So we are talking about opposite and hypotenuse here. Which trig ratio do you use when you have opposite and hypotenuse? Sine. So you say that sine of this angle, which is 45, so sine 45 is equal to opposite. Opposite is PR, that is what we are looking for, divided by hypotenuse, which is QR, or 10 centimeters, as we have here. Okay, so as soon as we write this equation, it becomes linear equation for us to simplify. So to simplify this linear equation, I'll multiply the left hand side by 10. I'll multiply the right hand side also by 10. So this will cancel the 10 out so that I'll have PR. So we are going to have PR is equal to 10 times sine 45. What is sine 45? You can find that on your calculator. So sine 45, so you click on sine. Remember, you are not finding sine inverse. This is sine, so you just click on sine, then you find sine 45, you close the bracket. Sine 45 is square root of 2 divided by 2. It means that you are going to have 10 times sine 45, which is square root of 2 divided by 2, is equal to PR. We need our answer in decimals, so we are going to have 10 times square root of 2 divided by 2, and that will give us, in decimals, we have 7.0716. I'll leave my answer to 2 decimal places, so PR is equal to 7.07. The unit is centimeters, so 7.07 centimeters. So using this trig ratio, we have been able to find the length of the side of the right-angled triangle. Let's consider PQ. How do we find PQ? We saw in the previous slide that PR is opposite to 45 degrees. So you can see that PQ is adjacent to 45 degrees. So we have PQ as adjacent. We know that this side is opposite. This side is the hypotenuse, which is RQ. So we have adjacent, we have hypotenuse. We are going to use cos. So we say that cos 45 degrees is equal to PQ, which is adjacent, divided by the hypotenuse, which is 10 centimeters. The hypotenuse is QR, but it has the length of 10 centimeters, so 10 centimeters. Once again, this is a linear equation that we have to solve. So I'll multiply the left hand side by 10, the right hand side by 10 to cancel out 10. You find cos 45 on your calculator. Now when you find cos 45 on your calculator, you will see that cos 45 is the same as sine 45. So cos 45 is also equal to square root of 2 divided by 2. So you have 10 times square root of 2 divided by 2 is equal to PQ. When you do this on your calculator, you see that PQ will also give us 7.07 centimeters. So you found PR to be 7.07 centimeters, and PQ is also equal to 7.07 centimeters. So you can see that using the trig ratios, you can find the interior angles here, the acute angles here, when the size of the right angle triangle is given to you. Or you can also find the length of the size of the right angle triangle when one of the sides or two of them and an interior angle has been given to you. Thank you for watching this video. Don't forget to like and subscribe if you haven't subscribed to this channel already. Share this link with others so that they can also enjoy the videos. In the next video, we are going to learn about the Pythagoras theorem. Bye-bye. We are on the topic trigonometry. In the previous video, we learned how to use the trig ratios to find the length of the sides of a right-angled triangle. In this video, we are going to learn about the Pythagoras theorem. What is the Pythagoras theorem? The Pythagoras theorem states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other sides. So what the Pythagoras theorem states is that if you have a right angle triangle like we have in this diagram here, A, B, C, the square of the hypotenuse, that is the square of the side AC, is equal to the sum of the squares of the other two sides. So the square of the side AC is equal to AB squared plus BC squared. So all that the Pythagoras theorem says is that if you have a right angled triangle like we have in this diagram, the hypotenuse squared, we've learned how to identify the hypotenuse. We said it is the longest side or the side facing the right angle. So in this diagram, the hypotenuse is AC. The hypotenuse squared is equal to the sum of the squares of the other two sides. So here, AB squared plus BC squared. From this diagram, we know that the hypotenuse is represented by h. So h squared is equal to AB is represented by x, so x squared, plus BC is represented by y, so y squared. So h squared is equal to x squared plus y squared. So the Pythagoras theorem states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other sides. Let's use what you've learned here to solve some questions. The first question, find the value of x in the diagram below. So here, the length AB is 4 meters, the length BC is 3 meters, and we are looking for the length AC. Remember, AC is the hypotenuse because it's the side facing the right angle, or it is the longest side. We know from the Pythagoras theorem that for this diagram, AC squared is equal to AB squared plus BC squared. We are looking for AC, and AC is x. So x squared is equal to AB is 4 meters, so 4 squared, plus BC is 3 meters, so 3 squared. You do this on your calculator, you are going to have x squared is equal to 16 plus 4, so x squared is equal to 25. You know from change of subject that when you get here, you take square root of both sides. So you take square root of the left hand side and you take square root of the right hand side, and x is giving us 5 meters. So using the Pythagoras theorem, we have been able to find x as 5 meters. Let's take another question. Find the value of x in this diagram. So this triangle is PQR. So from this triangle, we can see that QR is the hypotenuse. The other two sides are PQ and PR. From the Pythagoras theorem, we can say that QR, which is the hypotenuse, QR squared is equal to the sum of the squares of the other two sides. So QR squared is equal to PQ squared plus PR squared. So square the hypotenuse is equal to the sum of the squares of the other two sides. So here QR squared is equal to PQ squared plus PR squared. QR is what we are looking for, and that is x. So x squared is equal to PQ is 15, so 15 squared, plus PR is 12, so 12 squared. You do this on your calculator, you are going to have x squared is equal to 369. You take square root of both sides, and x is giving us 19.21 meters. So using the Pythagoras theorem, we have been able to find the length of QR, or x, the value of x, to be 19.21 meters. Let's take the next question. Find the value of y in the diagram below. This is a right angled triangle. So applying the Pythagoras theorem, we know that the length of the hypotenuse is mn. So mn squared is equal to km squared plus kn squared. The square of the hypotenuse is equal to the sum of the squares of the other two sides. So mn squared is equal to km squared plus kn squared. Remember that the hypotenuse is always the side facing the right angle. So here's the right angle. The side facing it is mn. So you square that side is equal to the sum of the squares of the other side. So km squared plus kn squared. Mn is 7 meters. We know that. So 7 squared is equal to km from the diagram is 4 centimeters. Sorry, mn is 7 centimeters, not 7 meters. So 7 centimeters squared plus 4 centimeters squared plus kn is y. So y squared. That is what we are looking for. So here we group like terms. 7 squared will give us 49, 4 squared will give us 16, so plus y squared. You group like terms, you get 49 minus 16 is equal to y squared. So we have 33 is equal to y squared. We take square roots of both sides and y is equal to 5.74 centimeters. So using the Pythagoras theorem, we have been able to find the value of y to be 5.74 centimeters. Let's pick the last question. Find the value of n in the diagram below. So this is another right angled triangle, UWV or UVW. The hypotenuse is VW. So here the length of the hypotenuse squared is equal to the sum of the squares of the other two sides. So the other two sides are UV and UW. So VW squared is equal to UV squared plus UW squared. From the diagram, VW is 13 centimeters. So 13 centimeters squared is equal to UV is n. So n squared plus UW is 11 centimeters. So 11 squared. 13 squared is 169. 11 squared is 121. You can do this on your calculator. You group like terms, you have 169 minus 121 is equal to n squared. This will give us 48 is equal to n squared. You take square root of both sides and n is equal to 6.93 centimeters. So using the Pythagoras theorem, you have been able to find n to be 6.93 centimeters. Thank you for watching this video. I hope this video was helpful. If it was, don't forget to like and subscribe to this channel if you haven't done that already. In the next video, we are going to apply what you've learned about the trig ratios and Pythagoras theorem to solve some questions. Bye-bye. We are on the topic trigonometry. In the previous videos, we have learned about the trigonometric ratios and how to use them to solve questions. We have also learned about the Pythagoras theorem and how to apply it in solving questions. In this video and the subsequent ones, we are going to learn how to apply both the trigonometric ratios and the Pythagoras theorem to solve some questions. So let's take the question for this video. Find in the figure below, triangle ABC is a right angled triangle. Find the value of y and theta. So we have been given this triangle ABC, and the question says it's a right angled triangle. So we can see the right angle here, which is the 90 degrees angle. It's on point C. So we are supposed to find y and theta. Now looking at this diagram very carefully, we know that if we apply the Pythagoras theorem, we have the length AB and the length AC. So we can use the Pythagoras theorem to find the length BC. If we're able to find the length BC, we can use any of the trigonometric ratios to find theta. So the first thing I'm going to do is to find y. To find y, I'm going to use the Pythagoras theorem. We've learned from the Pythagoras theorem in the previous video that the Pythagoras theorem says that in a right-angled triangle, the square of the hypotenuse, so in this triangle, AB is the hypotenuse, that is the longest side or the side facing the 90 degrees angle. So the square of the hypotenuse, so AB squared, is equal to the sum of the squares of the other two sides. So AB squared is equal to AC squared plus BC squared. AB is 41 centimeters, so 41 squared is equal to AC is 9 centimeters, 9 squared plus BC is y, that is what we are looking for, so y squared. This will give us 1681 is equal to 81 plus y squared. When we simplify this, we will get 1600 is equal to y squared. We take square root of both sides and y is giving us 40 centimeters. So using the Pythagoras theorem, we have been able to find the value of y to be 40 centimeters. So we can say that from here, y is equal to 40 centimeters. So we have y to be 40 centimeters. Now, we are looking for theta. We know that AC is opposite to theta and AB is the hypotenuse. BC is adjacent to theta, and we just found that to be 40 centimeters. So you can use any of the trig ratios to find it and you get the answer correct. Here I'm using here I'm using sine. So if I pick sine theta, remember from SOHCAHTOA, sine is opposite over hypotenuse. So here sine theta is equal to opposite, which is 9 centimeters, divided by the hypotenuse, which is 41 centimeters. From here, we say that theta is equal to sine inverse of 9 over 41. So theta will give us 12.7 degrees. Someone can also choose to use tan. So if the person uses tan, it's going to be tan theta is equal to opposite, which is 9 centimeters, divided by the adjacent, which is 40 centimeters. So theta will give us tan inverse of 9 over 40. And you are going to get 12.1 degrees. Somebody can also decide to use cos. Cos theta is equal to adjacent, 40 centimeters, divided by the hypotenuse, which is 41 centimeters. So cos inverse of 40 divided by 41, and you are going to get 12.7 degrees. So in any case, or it doesn't matter which one that you pick, you are going to get the same answer. So here I chose to use sine. So sine theta is equal to 9 over 41. So theta will give us sine inverse of 9 over 41, and that is giving us 12.7. And as I said, because you have all the three sides, you have the opposite, you have adjacent, you have hypotenuse, you can use any of the sign of the trig ratios and you still have the same answer. Thank you for watching this video. I hope what you watched in this video was helpful. If it was, don't forget to subscribe to this channel for more videos. In the next video, we are going to solve another question by applying the Pythagoras theorem and the trig ratios. Bye-bye. We are on the topic trigonometry. In the previous video, we applied the trig ratios and the Pythagoras theorem to solve a question. In this video, we are going to solve another question by applying the trig ratios and the Pythagoras theorem. So let's look at our question for this video. If theta is between 0 degrees and 90 degrees and tan theta is equal to 3 over 4, find sine theta and cos theta. So the question is telling us that this angle theta is between 0 degrees and 90 degrees, and tan theta is equal to 3 over 4, and we are supposed to find sine theta and cos theta. In the video on angles, we learned that an acute angle is an angle that is less than 90 degrees. So here, The question is telling us that theta is between 0 degrees and 90 degrees, which means that theta is an acute angle. Now, it goes on to say that tan theta is equal to 3 over 4. We know that we can find tan theta of an acute angle in a right-angled triangle. So it means that if we draw a right-angled triangle and we name one of the angles as theta, we can find tan of theta. So that is exactly what we are going to do. When you are being given a question like this, you draw a right-angled triangle. Since the question says that theta is between 0 degrees and 90 degrees, it means that theta can be one of these acute angles. So you are going to choose one of them. So in this case, I'm going to choose this angle here, and I'll call it theta because it's an acute angle. Now, if this is theta, the question says that tan theta is equal to 3 over 4. We know that tan theta is opposite over adjacent. So it means that in this diagram, the opposite to this diagram, which is BC, is 3. And the opposite to this angle, which is BC, is 3. And the adjacent to this angle, which is AB, is 4. So from here we can say that tan theta is equal to opposite, which is 3, over adjacent, which is 4. So it represents what we have here. We are looking for sine theta and cos theta. We know that sine theta is opposite over hypotenuse. So if we're able to find the hypotenuse, which is AC, we can find sine theta, and we can also find cos theta because cos theta is adjacent over hypotenuse. So that is exactly what we are going to do. We are going to find AC. We know AB, we know BC. We are looking for AC. This is a right-angled triangle. We are going to use the Pythagoras theorem to find AC. If we apply the Pythagoras theorem on this right-angled triangle, we are going to have AC squared is equal to AB squared plus BC squared, because AC is the hypotenuse, or the longest side, or the side facing the right-angled triangle, or the side facing the right angle, sorry. So AC squared is equal to AB squared plus BC squared. AB is 4, BC is 3. So you are going to have AC squared is equal to 4 squared plus 3 squared. And if you simplify this, you are going to have AC is equal to 5. So we can say that AC is 5. So now from our diagram, remember this is theta, this is opposite, which is 3, this is adjacent, which is 4. We have AC now to be 5. So from this diagram, if you want to find sine theta, we know that sine theta is opposite over hypotenuse. Opposite is 3, hypotenuse is 5. So sine theta is equal to 3 over 5. Remember, the question did not tell us to find theta. The question said that find sine theta. So sine theta is 3 over 5. It also said we should find cos theta. So from this diagram, cos theta is adjacent over hypotenuse. So 4 divided by 5. So cos theta is equal to 4 over 5. Once again, the question did not tell us to find theta. It told us to find sine theta and cos theta. And that is exactly what we have done. If it had said find theta, we would have found the sine inverse of 3 over 4 or cos inverse of 4 over 5. But it said we should find sine theta and cos theta. So we have been able to find sine theta to be 3 over 5 and cos theta to be 4 over 5. So when you have a question of this nature, just draw a right-angled triangle for the question that has been given to you, and you'll be able to solve it just as we've done here. Thank you for watching this video. I hope this video was helpful. If it was, don't forget to like and subscribe to this channel. In the next video, we are going to solve another question of this nature. Bye-bye. We are on the topic trigonometry. In the previous video, we applied the trigonometric ratios and the Pythagoras theorem to solve a question. In this video, we are going to solve another question by applying the trigonometric ratios and the Pythagoras theorem. So let's look at our question for this video. If 41 sine x is equal to 9, where x is between 0 degrees and 90 degrees. Find 1 plus cos x divided by 2 minus tan x. So the question is saying that 41 sine x is equal to 9, and x is between 0 degrees and 90 degrees, which means that x is an acute angle. So x is an acute angle, that is why it's between 0 degrees and 90 degrees. And we know that 41 sine x is equal to 9. Now look at something here. If we divide 41 sine x by 41, and we divide 9 by 41, you see that 41 will cancel 41 here. So you have sine x is equal to 9 divided by 41. We can say this from this equation. 41 sine x is equal to 9. So sine x is equal to 9 divided by 41. We also know that x is an acute angle, which means that if we draw a right angle triangle like this, we can name one of these acute angles as x. So I'm going to call this acute angle here x. If we have this acute angle, from this equation here, we know that sine x is equal to 9 divided by 41. But we also know that sine is equal to opposite divided by hypotenuse. So this x here, sine of x is equal to opposite, which is 9, divided by hypotenuse, which is 41. So from this diagram, we know that sine x is equal to opposite, which is 9, divided by hypotenuse, which is 41. I've explained how to identify the opposite and the hypotenuse. So here, opposite is 9, hypotenuse is 41. We need to find 1 plus cos x divided by 2 minus tan x. To do that, we first have to find cos x and tan x. Cos x will give us adjacent divided by hypotenuse, but we don't know the length of the adjacent side, so we have to look for that. The same way, tan x will give us opposite divided by adjacent. Once again, we don't know the adjacent side, which is AB, so we have to find AB. We have AC and BC. We need to find AB. This is a right-angled triangle. We can apply the Pythagoras theorem. From the Pythagoras theorem, we know that AC squared is equal to AB squared plus BC squared. So if we apply the Pythagoras theorem on this right-angled triangle, we will have AC squared is equal to AB squared plus BC squared. AC is 41, so 41 squared is equal to AB squared plus BC is 9, so 9 squared. This will give us 1681 minus 81, which is equal to AB squared. We have 1600 is equal to AB squared. So we take square root of both sides, and AB is equal to 40. So we have AB to be 40. So in this right angle triangle, we have our acute angle here, x. AC, which is the hypotenuse, is 41. BC, which is opposite to x, is 9. And AB, which is adjacent to x, is 40. So we can find cos x and tan x. From this diagram, we can say that cos x is adjacent, which is 40, divided by hypotenuse, which is 41. So cos x is equal to adjacent 40 divided by hypotenuse 41. Tan x is opposite 9 divided by adjacent, which is 40. So we have tan x is equal to 9 divided by 40. We now have cos x and we have tan x. So we can go ahead and find 1 plus cos x and divide it by 2 minus tan x. So you see that 1 plus cos x divided by 2 minus tan x is equal to 1 plus cos x is 40 divided by 41. So 1 plus 40 divided by 41 divided by 2 minus tan x is 9 divided by 40. So 9 divided by 40. So here we need to find the numerator, then we find the denominator. So the numerator is 1 plus 40 divided by 41. So 1 plus 40 divided by 41, and this will give us 81 divided by 41. So the numerator is 81 divided by 41. Let's find the denominator too. The denominator is 2 minus 9 divided by 40. So 9 divided by 40, and this will give us 71 divided by 40. So the numerator is 81 divided by 41. So 81 divided by 41. Then the denominator is 71 divided by 40. So we have 81 divided by 41 as the numerator, divided by the denominator, which is 71 divided by 40. If we do this on our calculator, we are going to have 81 divided by 41, then divided by 71 divided by 40, which is the denominator, and this will give us 3240 divided by 2911. So we are going to have 3240 divided by 2911. So we can say that 1 plus cos x divided by 2 minus tan x is equal to 3240 divided by 2911. So you see that applying the Pythagoras theorem and the trigonometric ratios, we have been able to solve this question. I hope you enjoyed this video and it was helpful to you. If it was, don't forget to like and subscribe to this channel. In the next video, we are going to apply the Pythagoras theorem and the trigonometric ratios to solve another question. Bye-bye. We are still on the topic trigonometry. In the previous video, we applied the trigonometric ratios and the Pythagoras theorem to solve a question. In this video, we are going to apply the trigonometric ratios and the Pythagoras theorem to solve another question. So let's look at our question for this video. Consider the diagram below and find x and y. Find the length DC. Give your answer in 3 significant figures. So this is the diagram. We have to consider it and find x and y. Then we find the length DC. Now, considering this diagram very carefully, we can see that there are 2 right-angled triangles. The first one is ABC. So triangle ABC is a right-angled triangle. Then triangle DBC is also another right-angled triangle. So we have one right-angled triangle inside another right-angled triangle. The question says that we should find x, that is the length AB, and we should find y, that is the length AD. Then we should find the length DC. So we are going to solve it one after the other. So let's pick the first one, which is the length AB. Now we can see that the length AB is the length x is in the right angle triangle ABC. So we are first going to consider triangle ABC alone. So from triangle ABC, this is triangle ABC, ABC. We can see that the angle here is 40 degrees as we have here. The length BC is 30 meters as we have here, 30 meters. And the length AB is x as we have here, x. Considering this triangle, we can see that x is opposite to 40 degrees and 30 meters is adjacent to 40 degrees. So we have the acute angle here, which is 40 degrees. We have x as opposite to it, and we have 30 meters as adjacent to it. So we have opposite, we have adjacent. Which trig ratio should we use? We are going to use tan, because tan is opposite over adjacent. So we can say that from this right angle triangle, tan 40 degrees is equal to opposite, which is x, divided by adjacent, which is 30 meters. Okay, so from here, we can simplify this equation and find x. I'm going to multiply the left hand side by 30, then I'll multiply the right hand side by 30. When I do that, you see that 30 will cancel 30. So we have 30 times tan 40 degrees is equal to x. 30 times tan 40 degrees will give us 25.2 meters. So if you do this and you correct your answer to 3 significant figures, you have 25.2 meters. I explained how to correct a number to a given significant figure in the videos on approximations. And I also explained how to use your calculator to do that. So if you watch that video, you will know how to correct a number to a given significant figures. So 30 times tan 40 corrected to 3 significant figures is 25.2 meters. So x is 25.2 meters. Let's move on to y. You can see that y is in the bigger triangle. That's triangle DBC. So if you want to find y, you have to consider triangle DBC. Okay, so considering triangle DBC, you see that this angle here will be the 20 degrees here plus the 40 degrees here, and that will give us 60 degrees. So the angle formed at C will be 20 degrees plus 40 degrees, that will be 60 degrees. The length DB or BD will be AB, which is x, plus AD, which is y. So the length BD or DB is x plus y. And so the length BC is 30 meters, as it can be seen here. So on this triangle too, we can see that x plus y is opposite to 60 degrees and 30 meters is adjacent to 60 degrees. So we have opposite, we have adjacent. So we are going to use tan. So we say that tan 60 degrees is equal to opposite, which is x plus y, divided by adjacent, which is 30 meters. Okay, so we have our equation here. So let's solve it. I'll multiply the left hand side by 30. I'll multiply the right hand side by 30 so that this 30 and that 30 will cancel. So 30 plus tan 60 degrees is equal to x plus y. 30 plus tan 60 degrees corrected to 3 significant figures is 52.0 meters. So we have x plus y. But don't forget that in the previous slide, we found the value of x. So we know that 50.0 is equal to x plus y, but we have found the value of x to be 25.2. So we can change x to 25.2 and find y. So we have 52.0 is equal to 25.2 plus y, because x is now 25.2. So 52.0 is equal to 25.2 plus y. If you make y the subject, you have 52.0 minus 25.2 is equal to y. And this will give us 26.8 meters. So you see that you have been able to find x to be 25.2 meters and y to be 26.8 meters. So using the trigonometric ratios, we have been able to find x to be 25.2 meters and y to be 26.8 meters. We've answered the first part of our question. It said we should find x and y, and we have done that. The second part of our question said we should find DC, the length DC. Okay, so that is exactly what we are going to do. Now you can see that the length DC is in the bigger triangle. So it is in triangle DBC. Okay, so you are going to consider triangle DBC. But look at something. We now know x, we now know y. So we can say that the length BD, so x is equal to 25.2 meters and y is equal to 26.8 meters. So the length BD is equal to x plus y. X plus y will give us 25.2 meters plus 26.8 meters, and that will give us 52 meters. So we know the length BC to be 30 meters and the length BD to be 52 meters. Okay, so if you are considering triangle DBC, we know that the angle here is 60 degrees. We know this length to be 30 meters. We know this length to be 52 meters. And we want the length DC. That's what the question told us to find. So this is a right angled triangle. We know BC to be 30 meters. We know BD to be 52 meters. And we want DC, which is the hypotenuse. We can apply the Pythagoras theorem. If you apply the Pythagoras theorem on this right angle triangle, you will see that DC, which is the hypotenuse, DC squared is equal to BC squared plus BD squared. We are looking for DC. So DC is equal to BC is 30 meters, so 30 squared plus BD, which is 52, so 52 meters, so 52 squared. So let's solve our equation. We will have DC squared is equal to 30 squared is 900, 52 squared is 2704. We add this, you are going to have DC squared is equal to 3604. You take square root of both sides. Correct your answer to 3 significant figures, and DC is equal to 60.0 meters. So using the Pythagoras theorem and the trigonometric ratios, we have been able to find x, y, and the length DC. Thank you for watching this video. I hope you enjoyed the video. If you did, don't forget to like and subscribe to this channel. In the next video, we are going to apply the Pythagoras theorem and the trigonometric ratios to solve another question. Bye-bye. We are still on the topic trigonometry. In the previous video, we applied the trigonometric ratios and the Pythagoras theorem to solve a question. In this video, we are going to solve another question by applying the trigonometric ratios and the Pythagoras theorem. So let's look at our question for this video. Find the length of PX and the length of QX in the figure below. Leave your answer in 2 decimal places. So if you consider this figure below, we can see that in this figure, we have triangle PSQ. We also have triangle PSR. Then we have the bigger triangle, which is triangle QPS. Okay. But we can only use our trigonometric ratios and the Pythagoras theorems in right-angled triangles. We can only use the trigonometric ratios and the Pythagoras theorem in right-angled triangles. So we are interested in the right-angled triangles in the diagram. The first right-angled triangle we can see is PSR because we have this right-angle sign here. But we know from plane geometry that angles on a straight line add up to 180 degrees. So if this angle here is 90 degrees, it means that this angle here is also 90 degrees. So it means that triangle PSQ is also a right-angled triangle. So we are interested in these two triangles because they are the right-angled triangles. So we can use our trigonometric ratios and the Pythagoras theorem on them. Okay, so let's go on. The question says that we should find PS, and QX. So let's consider the first triangle, triangle PSQ. You see we have QX and PS in it, so we can use that to find we can use triangle PSQ to find PS and QS. Now we know that from Q to R is 50 meters. It has been given to us. So if I call QS from Q to S, if I call that X, then SR will be 50 minus X. The whole thing is 50. So if I call QS as X, then SR will be 50 minus X. Okay. from triangle QSP. So QSP. So we are first considering this right angle triangle. From triangle QSP, we can see that tan 40. So tan is equal to opposite divided by adjacent. So tan 40 is equal to opposite, which is PS, because that is opposite to 40 degrees, divided by adjacent, which is QS. So tan 40 is equal to PS divided by QS. But we are saying from this diagram that QS is now X. So we can say that tan 40 degrees is equal to PS divided by X. We want to make PS the subject because that is what we want to find. So I'll multiply the left hand side by X and multiply the right hand side by X, and X will cancel. So I'll have X times tan 40, which will give us X tan 40 degrees is equal to PS. So I've made PS the subject here. Then I'll come to the second triangle, triangle PSR. If you are considering triangle PSR, we can say that tan 35 degrees, which is this acute angle here, is equal to opposite, which is PS, divided by adjacent, which is SR. So tan 35 degrees is equal to opposite, which is PS, divided by adjacent, which is XR. But from the diagram here, we are seeing that the adjacent, which is XR, is the same as 50 minus X, because from X to R is 50 minus X. So we can say that tan 35 degrees is equal to PS divided by SR, which is 50 minus X. We want to make PS the subject, so I'll multiply the left hand side by 50 minus X, then I'll multiply the right hand side by 50 minus X. So this 50 minus X will cancel this 50 minus X. So I'll say that 50 minus X times tan 35 degrees is equal to PS. So I found PS from the first diagram and I found PS from the second diagram. But it is the same PS we are talking about. PS from the first diagram is this. PS from the first right angle triangle is this. PS from the second right angle triangle is the same thing. So if PS is equal to S tan 40 degrees and the same PS is equal to 50 minus X times tan 35 degrees, then we can equate X tan 40 degrees and 50 minus X tan 35 degrees. So we will say that X times tan 40 degrees is equal to 50 minus X tan 35 degrees. So we are going to find X from here. We can find tan 40 degrees on our calculator. If you do that, you are going to have 0.839. So I corrected my answer to 3 decimal places. Usually, if you correct your answer to 3 decimal places, it's going to give you a more accurate figure than correcting it to 1 decimal place. So S times tan 40 is 0.839 is equal to 50 minus X times tan 35 degrees will give us 0.700 if you correct your answer to 3 decimal places. So X times 0.839 will give us 0.839X. Then 0.700 is the same as 0.7 times 50 minus X. So here it becomes a linear equation. So let's solve this linear equation. 0.839x is equal to 0.7 times 50. So you open the brackets. So that will give us 35 minus 0.7 times x, which will give us 0.7x. So we group like terms. We are going to have 0.839x plus 0.7x is equal to 35. So we will have 1.539x is equal to 35. We divide both sides by 1.539 and x will give us 22.74. Remember, the calculator said the question said we should correct our answer to 2 decimal places. So x is equal to 22.74. But from our diagram, s is QS. So we can say that QS is equal to 22.74. Don't forget the unit centimeters. So we have been able to find S, but S is QS. That is what the question told us to find. So QS is equal to 22.74 centimeters. So here we found PS using the first right angle triangle, and we found PS using the second right angle triangle. Then we equated the two answers. From there, we were able to find QS, and that is 22.74 centimeters. From one of the equations that we wrote, we saw that S tan 40 degrees is equal to PS. The question told us to find PS. We have been able to find X to be 22.74. So we can replace X with 22.74. So PS is equal to 22.74 times tan 40 degrees. So if you do this on your calculator, you are going to have 19.08 centimeters. So we have found S scale to be 22.74 centimeters and PS to be 19.08 centimeters. Thank you for watching this video. Don't forget to like and subscribe. In the next video, we are going to learn how to use trigonometry to solve practical problems. Bye-bye. We are on the topic trigonometry. In the previous video, we applied the trigonometric ratios and the Pythagoras theorem to solve a question. In this video and the subsequent ones, we are going to apply the trigonometric ratios and the Pythagoras theorem to solve practical problems. So when you have a practical problem, how do you use trigonometry to solve it? The first thing you need to do is to read the statement carefully. So you read the statement or the question that has been given to you very carefully. Then you draw an appropriate diagram for the statement or the question if a diagram was not given to you. So if the question gives you a diagram, fair enough. But if it doesn't, you have to draw an appropriate diagram. Then you use letters to represent the unknowns in the diagram. So what you want to find, maybe an angle or a given length, you use letters to represent it. Then you find the unknowns by using the Pythagoras theorem and the trigonometric ratios. So you apply the Pythagoras theorem and the trigonometric ratios to find the unknowns in the diagram. Let's pick a question and see how to do this. The question for this video is: a ladder leans against a vertical wall. If the foot of the ladder is 16 meters away from the wall and the height of the wall is 20 meters, find I, the vertical angle between the wall and the ladder. II, the length of the ladder. So in this question, a diagram was not given to us, so we have to draw the diagram ourselves. So we have the question here once again. It says that a ladder leans against a wall. So that's what we are going to do. We have this as our ground level, then we have this as the wall. Definitely the wall will be on the ground, so the wall is on the ground. Now the question is saying that a ladder leans against the wall. So there's this ladder that leans against this wall. Okay. If the foot of the ladder is 16 meters away from the wall, so if the ladder leans against the wall, this is the foot of the ladder. The foot of the ladder is the part of the ladder that is on the ground. So the part of the ladder that is on the ground is called the foot of the ladder. The question says that the foot of the ladder is 16 meters away from the wall. So from the foot of the ladder to the wall is 16 meters. So it means that from this point here to this point is 16 meters. And the height of the wall is 20 meters. So the height of this wall is 20 meters. So this wall is also 20 meters high. Find, correct your answer to 3 significant figures. I, the vertical angle between the wall and the ladder. The vertical angle between the wall and the ladder. Now you see, because the ladder is leaning against the wall, there will be an angle created between the ladder and the wall, which is this angle that we have here. So this particular angle. This angle is what we are talking about. The question is saying that we should find it. We should find the angle between the wall and the ladder. So this angle. And we should also find the length of the ladder. From here, you can see that this is the ladder. So you should find the length of this ladder. Now, you can see from here that the wall is on the ground. Looking at how the wall is on the ground, this side is a right angle, or the 90 degrees angle. So we can form a right angled triangle from this diagram. So we form this simple right angled triangle. This is the ladder, this is the ground level, and this is the wall. I'll call this point here point L. I'll call this point here point W. Then I'll call this point here point G. From the diagram here, you can see that between W and G is 20 meters. Between L and G is 16 meters. And this is the right angle, as we can see. So the question is saying that we should find the vertical angle between the wall and the ladder. We have seen that that is this angle here. So from our right angle triangle is going to be this angle. This is what we are looking for. It also said that we should find the length of the ladder. The length of the ladder from our drawing here, or from our right angle triangle here, would be LW. So we find LW. Okay, so let's go ahead and apply the Pythagoras theorem and the trigonometric ratios to find what we want. The question said that we should find the angle between the ladder and the wall. As you saw, if we let that angle to be equal to theta, on our diagram, you see that theta is this angle, because that is the angle between the ladder and the wall. So we are looking for theta. This is a right angle triangle. 16 meters is opposite to theta, and 20 meters is adjacent to theta. So we have opposite and we have adjacent. So we are going to use tan to solve for theta. So we can say that from this diagram, tan theta is equal to 16 meters divided by 20. So the meters and the meters will cancel. So we have tan theta is equal to 16 divided by 20. To find theta, you are going to find tan inverse of 16 divided by 20. So theta is equal to tan inverse of 16 divided by 20. We have learned how to find tan inverse on your calculator. So theta is equal to 38.7 degrees. So you press shift, then you press tan, and you enter 16 divided by 20. That will give you tan inverse of 16 divided by 20, which is 38.7 degrees. The question said we should correct our answer to 3 significant figures. So if you find this on your calculator and you correct your answer to 3 significant figures, you are going to have 38.7 degrees. If you watch the video on approximations, I explained how to correct your answer to a given significant figure. So it means that the angle between the ladder and the wall is 38.7 degrees. The question also said we should find the length of the ladder. From our diagram here, the length of the ladder is the length LW. So we have this as our right angled triangle. We know LG, we know GW or WG, and we want LW. Once again, this is a right angled triangle, so we can apply the Pythagoras theorem. If you apply the Pythagoras theorem on this right angled triangle, you will see that LW squared, which is the hypotenuse squared, is equal to LG squared plus GW squared. We want to find LW. We know LG, we know GW, so we can find it. So LW squared is equal to 16 squared plus 20 squared. You simplify this and you are going to get LW squared is equal to 656. You take square root of both sides and LW is equal to 25.6 meters. So if you find square root of 656 and you correct your answer to 3 significant figures, you have 25.6 meters. Once again, if you want to learn how to correct your answer to a given significant figures, watch the video on approximations. I explained how to do that and how to use your calculator to do that also. So the length of the ladder is 25.6 meters. So we can say that the ladder is 25.6 meters long. So applying the Pythagoras theorem and the trigonometric ratios, we have been able to solve this question. Thank you for watching this video. I hope you enjoyed it. If you did, don't forget to subscribe to this channel if you haven't done that already. In the next video, we are going to apply the Pythagoras theorem and the trigonometric ratios to solve another practical problem. Bye-bye. We are on the topic trigonometry. In the previous video, we solved a practical problem by applying the trig ratios and the Pythagoras theorem. In this video, we are going to solve another practical problem by applying the trig ratios and the Pythagoras theorem. So let's look at our question for this video. The question for this video is, in the diagram below, PS and QT are two ladders 10 meters and 12 meters long, respectively, placed against a vertical wall TR. PS makes an angle of 60 degrees with the horizontal and PQ is equal to 0.5 meters. Calculate correct to 4 significant figures: the angle which QT makes with the horizontal, the length TR. So this is the diagram for the question. Fortunately for us, a diagram was drawn, so you have to go straight ahead and solve the question. The question says that in this diagram, PS and QT are two ladders and their lengths are 10 meters and 12 meters respectively, which means that the length of PS is 10 meters. So the length of PS is 10 meters and the length of QT is 12 meters. So the length of QT here is 12 meters. And they are placed against this wall. The wall is TR. PS makes an angle of 60 degrees with the horizontal, as we can see here. And PQ is equal to 0.5 meters. So from P to Q is 0.5 meters. And we are supposed to calculate and correct our answer to 4 significant figures. The angle QT makes with the horizontal. Now this is the horizontal line. So the angle that QT makes with the horizontal is this angle. So this is the angle we will be looking for. This is the horizontal line. We have this as our horizontal line. And this is QT. So the angle that QT makes with the horizontal is this angle. Then from there, we are supposed to look for TR. That is the height of the wall. So TR. Let's first start with the angle. So here, we are looking for this angle here. Okay. So we are going to say that the angle between QT and the horizontal is equal to theta. So we are letting that angle to be equal to theta. So we can say that this angle here is theta. Now, how do we find theta? You can see that QTR is a right-angled triangle. So we can use this trig ratios to find theta. In the same way, PSR is also a right-angled triangle. Now, to find theta, we have QT as 12 meters, but we don't know TR. We also don't know QR. The question told us to find TR, which means that we are going to find that later on. So to help us to find theta, we will need to find QR so that we can use QR and QT to find theta. How do we find QR? We know that PQ is 0.5 meters, which means that from P to Q is 0.5 meters. So if you're able to find the length PR, we can subtract 0.5 meters from it to get QR. That makes sense, right? Because from P to R, if you subtract from P to Q from it, we are going to get Q to R. So if you're able to find PR and subtract PQ from it, we can get QR. Okay, so let's find PR. Using the right angle triangle PSR, we can find PR. So we are going to form this simple right angle triangle here. We have PSR. We know that from P to S is 10 meters as can be seen on the diagram. From P to R, that is what we are looking for. We also don't know SR. We don't know that one also. But we know here to be 60 degrees. We know the angle to be 60 degrees. And we know PS to be 10 meters. We are looking for PR. On this right angle triangle, we can see that PR is adjacent to 60 meters and PS is the hypotenuse. So we have adjacent, we have hypotenuse. So we are going to use cos. So we can say that cos 60 degrees is equal to PR, which is the adjacent, divided by PS, which is the hypotenuse. We know PS to be 10 meters. So cos 60 degrees is equal to PR divided by 10. To solve this, we multiply the left hand side by 60 by 10. We multiply the right hand side by 10. So this 10 and this 10 will cancel. So you see that 10 cos 60 degrees will give us PR. If you find 10 cos 60 degrees on your calculator, you are going to have 5. Don't forget the units that we are working in. So 5 meters. So it means that PR is equal to 5 meters. Okay. So now we know PR to be 5 meters, but we know that PR, that is moving from P to R, is equal to PQ plus QR. Okay, we have found PR to be 5 meters. We know that PQ is 0.5 meters. So we are going to have 5 meters is equal to 0.5 meters plus QR, which is what we are looking for. This will give us QR to be 4.5 meters. So we now have QR to be 4.5 meters. So we can say that from Q to R is now 4.5 meters. Now, we know QR to be 4.5 meters. We know that the angle here is theta. So the angle at Q is theta. And we know QT to be 12 meters. So we can find theta using 12 meters and 4.5 meters. Now you can see from here that QR is adjacent to theta and QT is the hypotenuse. So we have adjacent, we have hypotenuse. We are going to use cos. So cos theta is equal to adjacent, which is QR, divided by hypotenuse, which is QT. So cos theta will give us QR is 4.5 meters. QT is 12 meters. So cos theta is equal to 4.5 meters divided by 12. Theta will give us cos inverse of 4.5 divided by 12. You correct your answer to 4 significant figures and theta is equal to 67.98 degrees. So we can say that the angle between QT and the horizontal is 67.98 degrees. The question went on to say that you should find TR. TR is in the right angle triangle QTR. So if you draw the right angle triangle again, QTR. We now know QT to be 12 meters. We know QR to be 4.5 meters. We are looking for TR. We can apply the Pythagoras theorem to find TR. Okay, so from the Pythagoras theorem, if you are applying it on this right angle triangle, you will see that QT squared is equal to QR squared plus TR squared. So we are going to have QT is 12 meters, so 12 squared plus QR is 4.5, so 4.5 squared plus TR, which we are looking for. So you simplify this, and you are going to have 123.75 is equal to TR squared. You take square root of both sides, and TR is equal to 11.12 meters. Once again, we are correcting our answer to 4 significant figures. So if you find square root of 123.75 and you correct your answer to 4 significant figures, you are going to have 11.12 meters. So using the Pythagoras theorem and the trigonometric ratios, we have been able to find the angle that QT makes with the horizontal and the length TR. Thank you for watching this video. Don't forget to like and subscribe to this channel. In the next video, we are going to solve another practical problem by applying the trigonometric ratios and the Pythagoras theorem. Bye-bye. We are on the topic trigonometry. In the previous video, we applied the trigonometric ratios and the Pythagoras theorem to solve a practical problem. In this video, we are going to apply the trigonometric ratios and the Pythagoras theorem to solve another practical problem. So let's look at our question for this video. A ladder 10 meters leans against a vertical wall at an angle of 60 degrees to the ground. The ladder slips down the wall 4 meters. Find, correct to 3 significant figures, the new angle which the ladder makes with the ground. II, the distance the ladder slips back on the ground from its original position. So a diagram was not given to us. We are going to draw our own diagram. So here is the question once again. A ladder 10 meters leans against a vertical wall at an angle of 60 degrees to the ground. Okay, so if this is the ground, we know that we will have our wall on the ground. So this is the ground and this is the wall. Now the question says that this ladder leans against the wall. So the foot of the ladder will be on the ground, then the other part will be against the wall, as we can see here. The question goes on to say that the ladder leans against the wall and makes an angle of 60 degrees with the ground. So the foot of the ladder makes an angle of 60 degrees to the ground. Then the ladder is 10 meters long. So the length of the ladder is 10 meters long. The ladder slips down the wall. So this ladder that we have here, it slips down the wall, which means that the top part here slips down. So if the top part here slips down, the foot of the ladder is also going to go back, because if the top part here slips down, the foot of the ladder will not be at the same point here, so it's also going to go back. Now this is what we mean. The ladder from here slips to this point, and the question says that it slips by 4 meters. So it slips down the wall by 4 meters. So from here it slips 4 meters down. And as I said, if the original foot of the ladder was here, the foot of the original ladder was here, because it slipped, the foot will also go back to a certain point here. We don't know what it is. It goes on to say that we should find and correct our answer to 3 significant figures, the new angle which the ladder makes with the ground. Now you see that because it slipped down, the foot will also go back. Now if the foot goes back, it's going to create a new angle with the ground. So the question wants us to find this angle. It's the same ladder. The only thing here is that it has slipped down. So the foot here will also go back and create a new angle, as we can see here. The question wants us to find that angle. Then it also says that the distance the ladder slipped back on the ground from its original position. As I said, previously the ladder was here. So it's going to slip back. The foot is also going to slip back. So between the new position and the old position, the question says that we should find the distance. So the question wants us to find the distance from the new position here to the old position. So we are going to look for this distance. That is what the question wants us to find. So we are going to find 2 things here. We are going to find this angle and this distance. So this is our diagram for the question. To make it simpler, I'm going to use straight lines to represent all the lines that we have here. So this is the ladder, 10 meters. Remember that when it slipped down, the length of the ladder will not change. So it will still be 10 meters because it's the same ladder. Then this is the wall, okay, and this is the ground. I'm going to use this alphabet to name the point. So I'll call this point point A, I'll call here point B, here point C, E, F. Okay. From the diagram here, we can see that from this point to this point is 4 meters. So we can see the 4 meters here. And the angle created here is 60 degrees. So we can also see the angle here. The question wants us to find this angle. It wants us to find this angle. That is the first part of our question. See you in the next video where we will learn how to find this angle by applying the Pythagoras theorem and the trigonometric ratios. Bye bye. Welcome back, guys. In the previous video, we started solving this question and we drew the diagram for the question. In this video, we are going to find the angle that the ladder will make with the ground, the new angle the ladder makes with the ground, which is the first part of the question. So we drew this simple diagram for our question. We can see that in this diagram here, the wall meets the ground at this point, so it means that our right angle will be formed here. So it means that for this diagram too, the right angle will be formed here. Okay, so we are going to use this new diagram to solve for the new angle. Okay, so let the new angle the ladder makes with the ground equal to theta. Sorry. So we are calling the new angle the ladder makes with the ground as theta. We learned in the previous video that it is this angle here, which is angle theta. So we can see that the angle theta, once again, don't forget that here is the right angle. Okay, so that is our 90 degrees angle. So the angle theta is in the right angle triangle AEC. We know AE as 10 meters, but we don't know AC and we don't know EC. We have to find one of either EC or AC to help us to find theta. So that is our goal. So I'm going to choose EC. I'll find EC, then I'll use that with AE and find theta. EC is in the right angle triangle BFC. So considering the right angle triangle BFC, you can see that we have FE as 4 meters. So if I'm able to find FC and I subtract 4 meters from it, I can get EC. I hope that is clear. If I'm able to find FC and I subtract FE from it, I can get EC. Okay, so let's find FC. As I said, FC is in the right angle triangle BFC. So considering triangle BFC, we can say that sine 60 degrees, because the angle created here is 60 degrees as we have here. Sine 60 degrees is equal to opposite, which is FC, divided by the hypotenuse, which is BF. Okay, we know that BF is 10 meters, so we have 60 degrees is equal to FC divided by 10. You multiply the left hand side by 10, the right hand side by 10. 10 and 10 will cancel, so you have 10 sine 60 degrees is equal to FC, and this will give us, if you find this on your calculator, FC is equal to 8.66 meters. So FC is equal to 8.66 meters. We know from this diagram here that from F to C is equal to FE plus EC. We have found FC to be 8.66 meters. We know that FE is equal to 4 meters. So we have 8.66 meters is equal to 4 meters plus EC. And this will give us EC to be 4.66 meters. So it means that we have been able to find EC as 4.66 meters. So we now have AE and we now have EC. So we can find theta. If you draw this simple right angle triangle for triangle AEC, we can see that AE is 10 meters, EC is 4.66 meters. Using these two sides, we can find theta. Now look at something. EC is opposite to theta and AE is the hypotenuse. So we have opposite and we have hypotenuse. So we are going to use sine. So we can say that from the diagram AEC, sine theta is equal to opposite, which is EC, divided by hypotenuse, which is AE. So sine theta is equal to EC is 4.66 divided by 10, which is AE. So sine theta is equal to 4.66 divided by 10. So theta is equal to sine inverse of 4.66 divided by 10. So theta will give us 27.8 degrees. So we can say that the new angle the ladder makes with the ground is equal to 27.8 degrees, which means that when the ladder was in its original position, it was making an angle of 60 degrees with the ground. But after it slipped down by 4 meters, the foot of the ladder now makes an angle of 27.8 degrees with the ground. The question said you should find the distance AB, that is the length that the ladder slipped back. So the distance AB. We are going to find that in the next video. Welcome back. In the previous video, we found the new angle the ladder makes with the ground, and we were able to find out that is 27.8 degrees. We are now going to find the distance the foot of the ladder slipped back from its original position. So the foot of the ladder used to be at B. Because it slipped back, it came to A. So we are going to find the distance between A and B. Okay, so we can say that we are looking for this distance from A to B. That is what we are interested in. We are looking for the distance AB. Okay, so if we draw this right angle triangle here for the triangle AEC. So for triangle AEC, you can see that AB is in AEC. Now, before we can find AB, if we're able to find AC, then we find BC, and we subtract BC from AC, we can find AB. This is what I mean. From A to C, if you're able to find it, and we find BC, that is from B to C, we can subtract BC from AC, and that will give us AB. Okay, so considering this triangle AEC, we know that AE is 10 meters, and we also know that EC is 4.66 meters. So we can find AC from this triangle. Applying the Pythagoras theorem on this triangle, we will have AE squared is equal to EC squared plus the side we are looking for, which is AC squared. AE is 10 meters, so 10 squared is equal to 4.66 squared plus AC squared. You simplify this and you are going to have 78.2844 is equal to AC squared. You take square roots of both sides and you are having 8.85 meters. So AC, if you find this and you correct your answer to 3 significant figures, just as the question told us to do, AC will give you 8.85 meters. So we now have AC. Let's go ahead and find BC. To find BC, I'm going to draw this simple right angle triangle for the triangle BFC. So for BFC, we know that this is the 60 degrees angle. Here is our right angle, that is from point C. From B to F is 10 meters. Then from F to C will be 4 meters plus 4.66 meters, which will give us 8.66 meters. Because from F to C will be 4 meters plus 4.66 meters. So FC is 8.66 meters. So if you apply the Pythagoras theorem on this right angle triangle, you will see that BF squared is equal to FC squared plus BC squared. So BF is 10 meters, so 10 squared is equal to 8.66 squared plus BC squared. Okay, we simplify this and we are going to have 25.0044 is equal to BC squared. You take square root of both sides and BC will give us 5.00 meters. You correct your answer to 3 significant figures, so 5.00 meters. So we now have AC. We also have BC. We can see from this diagram that moving from A to C, or length AC, is equal to length AB plus length BC. We have AC and we have BC. So we will say that 8.85 meters is equal to AB, which we are looking for, plus BC, which is 5.00 meters. So you simplify this, you have 8.85 meters minus, sorry, so this is supposed to be in meters. This is in meters. Okay, so meters. So you have 8.85 meters minus 5.00 meters equal to AB. So AB will give us 3.85 meters. So we can say that the ladder slipped 3.85 meters back from its original position. So from the diagram here, we can see that at the top here, the ladder slipped 4 meters, but at the foot of the ladder, it slipped back 3.85 meters. So using the Pythagoras theorem and the trig ratios also, we have been able to find the distance the ladder slipped back from its original position on the ground. Thank you for watching this video. I hope this video was helpful. If it was, don't forget to like and subscribe. In the next video, we are going to learn how to apply the trigonometric ratios and the Pythagoras theorem to solve questions on angles of elevation and angles of depression. Bye-bye. We are on the topic trigonometry. In the previous video, we applied the trigonometric ratios and the Pythagoras theorem to solve a practical problem. In this video, we are going to learn about angle of elevation and angle of depression. Let's begin with angle of elevation. The angle of elevation of a point is the upward angle from the horizontal to the point. Let's use an example to explain this statement. Let's say that Mr. Kofi stands at this point here and there is a bird flying in the sky. Mr. Kofi wants to look at the bird. If he wants to do that, he will have to raise up his head, as we can see in this picture. Now you see, if he raises up his head like this, this will be his eye level. So from his eyes to the bird, we can draw a line from Mr. Kofi's eyes to the bird, as we can see here. But we know that on a normal day, Mr. Kofi's eyes will not be in the sky like this. On the normal day, this is Mr. Kofi's eye level. So this is his normal eye level. So we can see clearly from here that he has elevated his eye level to this point. This is his normal eye level. That is the horizontal that we have here. The angle of elevation of the bird from Mr. Kofi's eyes is the upward angle from the horizontal to the point, which in this case is the line joining Mr. Kofi's eyes to the bird. This is what these statements mean. This is the normal eye level of Mr. Kofi. This is the new eye level, or the elevated eye level. There will be an angle created between the elevated eye level and the normal eye level. That angle is what we call the angle of elevation. So the angle of elevation will be the angle created here, which we are going to call theta. So the angle we are calling here theta is called the angle of elevation. So in this case, the angle of elevation theta is the angle of elevation of the bed from Mr. Kofi's eyes. So you see that there's a line from Mr. Kofi's eyes to the bed. But this is his normal eye level, or the horizontal. The upward angle created between the elevated eye level and the normal eye level is what we call the angle of elevation. So you see that in this diagram, theta is the angle of elevation of the bed from Mr. Kofi's eyes. Let's consider the angle of depression. We learned that the angle of elevation of a point is the upward angle. We just learned that. The angle of depression, on the other hand, is the downward angle from the horizontal to the point. The angle of depression of a point is the downward angle from the horizontal to the point. Let's illustrate this with another example. Let's say that this time Mr. Kofi is on a cliff, as we can see here, and he spots a building on the ground. He wants to look at the rooftop of the building. He will have to bend his eyes, as we can see in the picture. So if we draw a line from his eyes to the top of the building, it will look like this. But we know that on a normal day, Mr. Kofi's eye level is horizontal. So this is the horizontal, his normal eye level. So you see that this is the horizontal, but his eye level is now bent. So there will be a downward angle from the horizontal to this line. That downward angle is what you call the angle of depression. So in this case, the angle created here, this downward angle created here, is the angle of depression of the top of the building from Mr. Kofi's eyes. So angle of elevation is the upward angle, but angle of depression is the downward angle. So here we can say that theta is the angle of depression of the top of the building from Mr. Kofi's eyes. Thank you for watching this video on angle of elevation and angle of depression. In the next video, we are going to apply the trigonometric ratios and the Pythagoras theorem to solve questions involving angle of elevation and angle of depression. Bye-bye. We are on the topic trigonometry. In the previous video, we studied angle of elevation and angle of depression. In this video, we are going to apply the trigonometric ratios and the Pythagoras theorem to solve practical problems that involves angle of elevation or angle of depression. So let's look at our question for this video. The angle of elevation of the top of a tower from a point on the ground 45 meters away from the foot of the tower is 30 degrees. Find the height of the tower. Correct your answer to 1 decimal place. A diagram was not given to us in this question, so we will have to draw our own diagram. So let's read the statement again and use it to draw a diagram. The angle of elevation of the top of a tower from a point on the ground 45 meters away from the foot of a tower is 30 degrees. So from here, we need the ground level, and the question says that there is a tower on the ground. So this is the ground level and there is this tower on the ground. It says that the angle of elevation of the top of the tower, so we are looking for the angle of elevation of the top of the tower from a point on the ground. So there is this point on the ground. Let's say that this is the point. The angle of elevation of the top of the tower from a point on the ground 45 meters away from the foot of the tower. So the question says that this point here is 45 meters away from the foot of the tower. So between this point and the foot of the tower, this is the tower, so here will be its foot. Between this point and the foot of the tower is 45 meters. Then it says that the angle of elevation of the top of the tower from this point here is 30 degrees. So from here, if this is the horizontal, the angle of elevation of the top of the tower from this point here is 30 degrees. So if we draw a line from this point here to the top of the tower, the upward angle, the upward angle here that will be created is the angle of elevation. The question is saying that that angle is 30 degrees. So the upward angle that we can see here is 30 degrees. So we can say that then that angle there is 30 degrees. We should use this diagram to find the height of the tower. So we are looking for the height of this tower. Okay, so I'm going to draw a simple right angle triangle from this. As we can see here, the tower meets the ground at this point here. So this side will be our 90 degrees angle. Okay, so we can draw our right angle triangle from the diagram. So I'm going to call this point here point A. I'll call this point here point B. Then I'll call this point here point C. This angle here is 30 degrees. From point A to point B is 48 meters, as we can see here. The question says that we should find the height of the tower. Now, from this diagram, you can see that the height of the tower is BC. BC will give us the height of the tower. So let's use this information to find BC. So we say that from the diagram, the height of the tower is equal to the length BC. Now look at something. We have this angle here to be 30 degrees. BC is opposite to 30 degrees and AB, which is 45 meters, is adjacent to 30 degrees. We have 30 degrees, we have 45 meters, so we can find BC. As I said, BC is opposite to 30 degrees. AB is adjacent to 30 degrees. So we have opposite and we have adjacent. We can use the trigonometric ratio tan to find the value of the length BC. So from the diagram, we can see that tan 30 degrees is equal to opposite, which is the length BC, divided by adjacent, which is the length AB. So tan 30 degrees is equal to BC divided by AB is 48 meters, so 48. We are going to make BC the subject, so I'll multiply the left hand side by 48, I'll multiply the right hand side by 48. So 48 and 48 will cancel out. So 48 tan 30 degrees is equal to BC. Remember, the question said we should correct our answer to one decimal place. So find 48 tan 30 degrees on your calculator and correct your answer to one decimal place. And that will give us 27.7 meters. So we can say that the height of the tower is 27.7 meters. So you see that we have been able to apply the trigonometric ratios to find the height of this tower, and we got 27.7 meters. Thank you for watching this video. Don't forget to like and subscribe to this channel if you haven't done so. In the next video, we are going to solve another question on angles of elevation and depression by applying the trigonometric ratios and the Pythagoras theorem. Bye-bye. We are on the topic trigonometry. In the previous video, we solved a practical problem that involves angles of elevation or depression. In this video, we are going to solve another practical problem that involves angle of elevation or depression. So let's look at the question for this video. Ni is 1.5 meters tall. He stands 20 meters away from a building which is 30 meters high. Determine the angle of elevation from his eyes to the top of the building. Correct your answer to two significant figures. Once again, a diagram was not given to us in this question, so we have to draw our own diagram. So let's read the question again. Ni is 1.5 meters tall. He stands 20 meters away from a building which is 30 meters high. So Ni stands on the ground like this. So this is the ground level and he is 1.5 meters tall. The question says that he stands 20 meters away from a building. So let's say that this is the building. The question is telling us that between me and the building is 20 meters. He is 20 meters away from the building. And the building is 30 meters high. So from the ground level to the topmost part of the building is 30 meters. It says that we should determine the angle of elevation of his eyes to the top of the building. So from his eyes to the top of the building, we should determine the angle of elevation. Now we know that on a normal day, this is Ni's normal eye level, but we want the angle of elevation from his eyes to the top of the building. Sorry, we want the angle of elevation from his eyes to the top of the building. We can see from this diagram that that would be this angle, the angle created between this line and his normal eye level. So the angle of elevation from the top of the building, from his eyes to the top of the building, will be this angle here. That is what we are interested in. That is the angle we want to find. Okay, so I'm going to draw a simple diagram here for this. Remember that in an examination, you don't have to draw this type of diagram. You can draw the simple one like this straight away. I do this to help you to visualize the question so that drawing the diagram becomes easy for you. Okay, so I'm going to use this line here to represent Ni. He is 1.5 meters long. So I'll call this point here point A. Here, the top of his head, I'll call that point E. I'll call this point here point D. Here, I'll call it point C. And here will be point B. So here will be 90 degrees. This side will also be 90 degrees. Okay, and the question is saying that we should find this angle here. So that is the angle we are interested in. So you say that let the angle of elevation from Ni's eyes to the top of the building equal to theta. So this angle here is theta. So from this diagram, we are looking for theta. Okay, to help us find theta, we need at least two sides of this triangle ECD or EDC. We need at least two sides of this triangle to help us to find theta. You can see clearly from here that AB is equal to EC. So AB is equal to EC. So if AB is 20 meters, then EC is also 20 meters. So we can say straight away that AB is equal to EC. So if AB is 20 meters, then EC is also 20 meters. We can also see from this diagram that DB, that is from D to B, is equal to DC plus CB. So if you add DC to CB, you get DB. Now from here, we can see clearly that DB is 30 meters. So 30 meters is equal to DC. We don't know that. That is what we are looking for. Plus CB is 1.5 because EA is equal to CB and EA is 1.5. So CB is also 1.5. So we can find DC from here. You simplify, DC will give us 28.5 meters. So we can say that DC is 28.5 meters. We have also found EC to be 20 meters. Okay, so we have found DC to be 28.5 meters. We have also found EC to be 20 meters. So DC is equal to 28.5 meters. EC is equal to AB, which will also give us 20 meters. Now applying tan theta to this triangle ECD. Tan theta is equal to opposite, which is DC, divided by adjacent, which is EC. So tan theta is equal to opposite, which is DC, divided by adjacent, which is EC. So tan theta is equal to opposite is 28.5 meters because opposite is DC. so 28.5 divided by adjacent, which is, opposite is DC, which is 28.5 meters, divided by adjacent, which is EC, then that will give us 20 meters. So to help us find theta, we are going to find tan inverse of 28.5 meters divided by 20. When you do this on a calculator, you are going to get theta is equal to 55 degrees. So we can say that the angle of elevation from knee eyes to the top of the building is 55 degrees, which means that if knee stands at this point, he will have to raise his eyes 55 degrees in order to look at the top of the building. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to solve another question that involves angle of elevation or depression. Bye bye. We are still on the topic trigonometry. In the previous video, we solved a practical problem that involved angle of elevation. In this video, we are going to solve another practical problem that involves angle of depression. So let's look at our question for this video. The angle of depression of a point X on the ground from the top of a building is 61 degrees. If the distance of the point X from the foot of the building is 35 meters, calculate the height of the building. Correct your answer to the nearest whole number. So you have to draw a diagram for this question. The angle of depression of a point X on the ground from the top of a building is 61 degrees. So we are talking about the ground level here, and there is a building on the ground. So you have the ground level and this is the building on the ground. The question says the angle of depression of a point X on the ground from the top of a building is 61 degrees. So let's say that this is the point X on the ground. This is the point. The angle of depression of X from the top of the building is 61 degrees. Now, if we are at the top of the building, this is the horizontal line. So the angle of depression of X from the top of the building, it means that if we join X to the top of the building, this angle that will be created here will be the angle of depression. So this angle here is the angle of depression of X from the top of the building. I hope that is clear. So our angle here, you see at the top of the building, this is the horizontal line. This is the normal line, the normal horizontal line. Now, the angle of depression of X from the top of the building, it means that we will have to join the top of the building to X. This downward angle, the downward angle that will be created is what we call the angle of depression. So in this case, this angle of depression is the angle of depression of X from the top of the building. So we can see that from this diagram, this angle here is 61 degrees. So the angle here is 61 degrees. The question goes on to say that if the distance of the point X from the foot of the building is 35 meters, so X from the foot of the building, this is the foot of the building. So it's telling us that the distance between X here and the foot of the building is 35 meters. So from X to the foot of the building is 35 meters. We should calculate the height of the building. So we have to determine how high the building is. Okay, so this is our diagram to draw our right angle triangle from the diagram. As we can see here, the building meets the ground at 90 degrees, so here will be the right angle. Okay, if you watch the video on angle properties of power lines, you can see that this line here is a horizontal line. Okay, this line is also another horizontal line. So these two lines will be parallel. this line and the line representing the ground level will be parallel lines. That means that this line here will be a transversal crossing the two parallel lines. If you have this parallel line and a transversal, then the angle created here, which is 61 degrees, will be alternating with the angle created here. We explained this into details in the video on angle properties of parallel lines under plane geometry. You will see that 61 degrees and this angle here are alternating angles. Alternating angles are equal. So if here is 61 degrees, then this side is also 61 degrees. So here is also 61 degrees. Okay, so I'm going to call this point here point X. The question said it's point X, so you have to name it point X. But we don't know the name of this, we don't know the name of this, so I will assume that here is Z and here is Y. We have our right angle here. The distance between this point and this point from the diagram is 35 meters. We need the height of the building. From the diagram here, the height of the building is YZ or ZY. So that is what we have to find. Okay, so we have our right angle triangle here. From the diagram, the height of the building is the distance YZ or the magnitude of YZ. Looking at this diagram very carefully, we can see that YZ is opposite to 61 degrees and YX or XY is adjacent to 61 degrees. So we have opposite and we have adjacent. So we can use tan. Okay, so we can say that from triangle XYZ, tan 61 degrees is equal to opposite, which is YZ, divided by adjacent, which is XY. We know XY from the diagram to be 35 meters. So 61 degrees is equal to YZ divided by XY, which is 35 meters. So we multiply the left hand side by 35, we multiply the right hand side by 35. So 35 and 35 will cancel. So we have 35 times 61 degrees is equal to YZ. So you find this on your calculator. The question said we should correct our answer to the nearest whole number. So you find this on your calculator and you correct your answer to the nearest whole number, and that will give us 63 meters. So YZ, which is the building, is 63 meters. So we can say that the building is 63 meters high. The building is 63 meters high. So you can see from here that we have applied the trigonometric ratios to find the height of the building. Thank you so much for watching this video. In the next video, we are going to solve another question that involves either angle of elevation or depression, or both of them. Bye-bye. We are on the topic trigonometry. In the previous video, we solved a question that involved angle of depression. In this video, we are going to solve another practical problem that involves angle of depression. So let's look at the question for this video. From a horizontal distance of 8.5 kilometers, a pilot observes that the angle of depression of the top and base of a control tower are 30 degrees and 33 degrees respectively. Calculate, correct to 3 decimal places, the shortest distance between the pilot and the base of the control tower. B, the height of the control tower in meters. Okay, so a diagram was not given to us, so you have to draw our own diagram for this question. It says that from a horizontal distance of 8.5 meters, a pilot observes that the angle of depression of the top and base of a control tower are 30 degrees and 33 degrees respectively. So there is a pilot. We know that pilots are in airplanes, so let's bring this airplane. So we have the pilot in this airplane here. Okay. Now this is the ground level. The control tower is on the ground. So the control tower is on the ground here. and the pilot is in the air. It says that from a distance of 8.5 kilometers, it means that between the pilot and the control tower is 8.5 meters. From a distance of 8.5 meters, a pilot observed that the angle of depression of the top and base of a control tower are 30 degrees and 33 degrees respectively. So between the pilot and the control tower is 8.5 kilometers. So from the pilot to the control tower is 8.5 kilometers. From this distance, he observes that the angle of depression of the top and base of the control tower are 30 degrees and 33 degrees respectively. This means that the angle of depression of the top is 30 degrees and the angle of depression of the base is 33 degrees. So from here, this is the normal eye level of the pilots. This is the normal eye level. So the angle of depression of the top is 30 degrees, which means that if we draw a line from the pilot to the top of the control tower, the angle of depression is 33 degrees. So the angle of depression is 30 degrees. So it means that this downward angle is 30 degrees. It also says that the angle of depression of the base is 33 degrees. So if we draw a line once again from the pilot to the base of the control tower, the downward angle from the horizontal to that line will give us 33 degrees. So the downward angle from the horizontal to this line here is 33 degrees. So the angle of elevation of the top is 30 degrees. The angle of depression of the top is 30 degrees and the angle of depression of the base is 33 degrees. The distance between the pilot and the control tower is 8.5 kilometers. So we have every information here on the diagram. It says that we should calculate the shortest distance between the pilot and the base of the control tower. We will find out what that is. And we should find the height of the control tower and we should give our answer in meters. Okay, so here's the diagram. If we join this line here with short dashes to meet this line, we can use these 3 points here as a right angle triangle as we have here. So in that case, this side is going to be our right angle. So here is going to be our right angle here as we can see here. I'm using the point P to represent the tower. I'll call this point here point C. Now, this is the control tower. So I'll call the top of the control tower B and the bottom I'll call it A. So I'll call the top part B, then I'll call the bottom part A. Okay, we know that from this line here, this horizontal line to this line is 30 degrees as you can see here. We also know that from this horizontal line here to this line is 33 degrees. But look at something. From here to here is already 30 degrees. So it means that the small angle is 3 degrees. Because if you add 3 to 30, you get the whole thing here, which is 33 degrees. From P to C, as you can see from the diagram, is 8.5 kilometers. So you have been able to represent this information here on this right angle triangle. The question says that we should calculate the shortest distance between the pilot and the foot of the control tower. We will learn how to do that in the next video. Welcome back. In the previous video, we started solving this question and we drew the diagram for this question. In this video, we are going to calculate the shortest distance between the pilot and the base of the control tower, which is the first part of our question. Okay, so we are going to determine the shortest distance between the pilot and the base of the control tower. So this was the right angle triangle that we obtained from the question. Now look at something very well. The question is telling us to determine the shortest distance between the pilot, which is P, and the base of the control tower, which is A. Don't forget that AB is the control tower. B is the top part of the control tower and A is the base or the bottom of the control tower. Okay, so we want the shortest distance between P and A. Now from this diagram, if someone wants to move from P to A, you can either move from P to C, then from C to A, or move from P to A straight away. So the question wants us to determine which one is shorter. You can clearly see from the diagram that moving from P to A will be the shortest distance between P and A. So the question actually wants us to find PA. So from the diagram, the shortest distance between the pilot P and the base of the control tower, which is A, is PA. So the question wants us to find PA. PA is part of the triangle PCA. So if we draw this small right angle triangle PCA, we will know that the total angle here is 33 degrees. So PCA, which means that the total angle there is 33 degrees. From P to C is 8.5 kilometers. Okay, and we want PA. From this diagram here, we can see that PA is the hypotenuse because it is the side facing the 90-degree angle, or it is the longest side. And 8.5 kilometers is adjacent to 33 degrees. So we have the adjacent side. We are looking for hypotenuse. Adjacent hypotenuse. Remember SOHCAHTOA. So we are going to use CA, which is cos, because that will give us adjacent hypotenuse. So we can say that from this diagram, or from the triangle PCA, cos 33 degrees is equal to PC divided by PA. PC is the adjacent, PA is the hypotenuse. So cos 33 degrees is equal to PC is 8.5 divided by PA, which is the distance we are looking for. So I'll multiply the left hand side by PA, I'll multiply the right hand side by PA. So PA and PA will cancel. So PA here will cancel PA. I'll get PA cos 33 degrees is equal to 8.5. From linear equations, we know that we have to divide both sides by cos 33. So we divide the left hand side by cos 33, we divide the right hand side by cos 33. And when you find, so this one will cancel this, you get PA. If you find 8.5 divided by cos 33 on your calculator, and you correct your answer to 3 decimal places, you are going to have 10.135 kilometers. So we can say that the shortest distance between the pilot and the base of the control tower is 10.135 kilometers. The question also said that we should determine, or we should calculate the height of the control tower. We are going to do that in the next video. Welcome back. In the previous video, we solved the shortest distance between the pilot and the base of the control tower, and we had 10.135 kilometers. We are going to concentrate on the last part of our question, that is the height of the control tower. In the diagram, the height of the control tower is BA. So the height of the control tower will give us BA. So that is what we are looking for. Now consider this diagram very carefully. We can see that from C to A is equal to C to B plus B to A, and we are looking for BA. So it means that if we're able to find CA and we find CB and we subtract CB from CA, we can get BA. We can find CB and CA because they are both in right angled triangles. So you can either use the Pythagoras theorem or use the trig ratios to find it. It will be difficult finding BA straight away because the triangle PBA is not a right angled triangle. but we know that PCB and PCA are both right angle triangles, so we can find CA and CB. Then we subtract CB from CA to get BA. Okay, so let's begin with the triangle PCB so that we'll be able to find CB. So I'll draw a small right angle triangle here. So PCA, the angle here is 30 degrees. So you see that for PCB, the angle here is 30 degrees. From P to C is still 8.5 kilometers. Okay, we are looking for CB. CB is opposite to 30 degrees and PC is adjacent to 30 degrees. So we have opposite, we have adjacent. So we are going to use tan. So you say that tan 30 degrees is equal to CB, which is opposite, divided by PC, which is adjacent. Okay, so tan 30 degrees is equal to CB divided by PC is 8.5. So we multiply the left hand side by 8.5, we multiply the right hand side by 8.5. And this will give us 8.5 tan 30 degrees is equal to CB. You find this on your calculator, you correct your answer to 3 decimal places, and you have CB equal to 4.907 kilometers. Okay, let's find CA. We have found CB, so let's find CA. To find CA, we are going to use the triangle PCA. So PCA. So considering triangle PCA, PC is still 8.5 kilometers, as you can see from here, but the angle is 33 degrees because we are talking about the bigger triangle PCA. So the angle here is 33 degrees. We are looking for CA. CA is opposite to 33 degrees and PC is adjacent to 33 degrees. So from triangle PCA, tan 33 degrees is equal to opposite, which is CA, divided by adjacent, which is PC. PC is 8.5. So you multiply the left hand side by 8.5, you multiply the right hand side by 8.5, and CA will give us 8.5 tan 33 degrees. You find this on your calculator and you correct your answer to 3 decimal places. You are going to get 5.520 kilometers. So now we know that CA is equal to CB plus BA. We are looking for BA. We now know CA, we know CB. So CA is 5.520 kilometers is equal to CB, which is 4.907 kilometers plus BA. So if you simplify this, you have 5.520 kilometers minus 4.907 kilometers is equal to BA. And this will give us 0.613 kilometers equal to BA. Remember, the question said we should find the height of the control tower in meters. Our answer here is in kilometers. If you want to convert a number from kilometers to meters, multiply that number by 1000. So if you multiply 0.613 kilometers by 1000, you are going to have 61.3 meters. So we have converted this answer from kilometers to meters. So BA, which is the height of the control tower, is 61.3 meters. So we can say that the control tower is 61.3 meters high. So in this question too, we have applied the trigonometric ratios to find the height of the control tower and the shortest distance between the pilot and the base of the control tower. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to solve another question that involves angle of elevation or depression. Bye-bye. We are on the topic trigonometry. In the previous video, we solved a practical problem that involved angle of depression. In this video, we are going to solve a practical problem that involves angle of elevation. So let's look at our question for this video. The feet of two vertical poles of height 3 meters and 7 meters are in line with a point P on the ground. The smaller pole being between the taller pole and P at a distance of 20 meters from P. The angle of elevation of the top of the taller pole, the angle of elevation of the top of the taller pole from the top of the smaller pole is 30 degrees. Calculate A. The horizontal distance between the poles. B. The distance of the foot of the taller pole from P. C. The angle of elevation of the top of the taller pole from P. A diagram was not given to us, so we are going to draw our own diagram for this question. Okay, so it says that the feet of two vertical poles of height 3 meters and 7 meters are in line with a point P on the ground. Okay, so there's the ground here, and there's this point P on the ground. The feet of two vertical poles are in line with P on the ground. So it means that there's this vertical pole here, which is 3 meters, that's the shorter one. Then there's another vertical pole, which is 7 meters, which is the taller one. That is what the question told us. And they are in line with P, so they are on the same horizontal line. It says that the shorter pole is between point P and the taller pole. So the shorter pole being between the taller pole and P at a distance of 20 meters from P. So from P to the shorter pole is 20 meters. So from P to the shorter pole, 20 meters, as we can see here. It goes on to say that the angle of elevation of the top of the taller pole from the top of the shorter pole is 30 meters. So at the top of the shorter pole, this is the horizontal line. Now from the top of the taller pole to the top of the shorter pole, we can draw this line to join them. The upward angle that will be created here, that is the angle of elevation. And the question says that it is 30 degrees. It goes on to say that we should find the horizontal distance between the poles. So we should find the horizontal distance between the two poles. So we are looking for this horizontal distance from here to here. It also says that we should find the distance from P to the foot of the taller pole. So the distance from P to the foot of the taller pole, which is here. So we should find from P to this point. We know that from P to this point is 20 meters. So we should find from P to the foot of the taller pole. And we should find the angle of elevation of the top of the taller pole from P. So the angle of elevation of the top of the taller pole from P. Okay, so this is the diagram that we drew. So we are going to form our right angle triangles from it. So I'm going to call this point here point P. That's what the question told us. We know that from P to this point here is 20 meters. So I'll call the base of the shorter pole S. I'll call the base of the taller pole T. I'll call the top part of the shorter pole R, and the top part of the taller pole, I'll call it V. I'll call this point here point Q. So this shorter dashes here, I'll join it to form a line. So I'll call that point Q. We have here point R. Okay, we know that the shorter pole is 3 meters, as can be seen here. So 3 meters. The taller pole is 7 meters, as it can also be seen here. We have 7 meters. The angle of elevation here is 30 degrees, as it can be seen here. The first part of the question says that we should calculate the distance between the two poles. So the distance between the horizontal distance between the two poles. So we are looking for this distance ST. That is what the question wants us to find. and we are going to do that in the next video. So see you in the next video where we will continue solving this question. Welcome back. In the previous video, we started solving this question and we drew this diagram for the question. We are going to continue with the solution in this video. So the first part says that we should calculate the horizontal distance between the poles. That is exactly what we are going to do. So this is our diagram. The horizontal distance between the poles will be ST, as can be seen from the diagram. Now look at this, what is happening here. From X to R is 3 meters. So we can say that from T to Q is also 3 meters. But we know that from V to T is 7 meters. So if from T to Q is 3 meters, then from V to Q will be 4 meters, because 4 plus 3 will give us 7. Okay, so from V to Q is 4 meters, and from Q to T is 3 meters, because from R to S is 3 meters. We are looking for ST, but looking at this diagram, we can say that ST is equal to RQ. So if you're able to find RQ is the same as ST. RQ is in the right angle triangle RVQ. So we can find RQ from there. So if you consider the triangle RVQ, you will see that VQ is opposite to 30 degrees and RQ is adjacent to 30 degrees. So tan theta degrees is equal to VQ divided by RQ, because tan is opposite divided by adjacent. We are looking for RQ. We know VQ. We know tan theta degrees, so we can find RQ. Okay, so tan 30 is, we know tan 30 degrees, so we can find RQ. So tan 30 degrees is equal to VQ, which is 4 meters, divided by RQ. I'll multiply the left hand side by RQ and multiply the right hand side by RQ. And this will give us RQ tan 30 is equal to 4, because RQ will cancel RQ. We divide both sides by 30 degrees. So this tan 30, we divide both sides by tan 30 degrees. So tan 30 will cancel tan 30. RQ is equal to 4 divided by tan 30 degrees, and that will give us 6.93 meters. So we have been able to find RQ to be 6.93. So we can say that since ST is equal to RQ, then ST is also 6.93 meters. So RQ is equal to 6.93 meters, and so ST is also equal to 6.93 meters. So we can say that the distance between the two poles is 6.93 meters. So the distance between these two poles is 6.93 meters. Okay, the next part of the question says that we should calculate the distance from P to the foot of the taller pole. So this is the foot of the taller pole, point T, and this is P. We have been able to find ST to be 6.93 meters. So the distance from P to T will be the distance from P to the foot of the taller pole, that is PT. From the diagram here, we can see that PT is equal to PS plus ST, and that will give us 20 meters plus 6.93 meters, which will give us 26.93 meters. So the foot of the taller pole is 26.93 meters away from P. So the foot of the taller pole is 26.93 meters away from P. Let's consider the last part of the question. It said we should calculate the angle of elevation of the top of the taller pole from P. So we are looking at the top of the taller pole, which is V, from P. So you draw a line from V to P. So the angle of elevation is the upward angle from the horizontal to the line. And that angle, we are going to call it theta. Okay, so we are looking for this angle here, angle theta. So we are going to consider this bigger right angle triangle, PVT. Remember that this angle here, remember that this angle here is a right angle. Okay, so if that is a right angle, then we can consider the right angle triangle PVT so that you'll be able to find theta, which is the angle of elevation of the top of the taller pole from P. Okay, so if you are considering triangle PVT, we know that from P to T is 26.93 meters. We just found that. VT, from the diagram here, you can see that that is 7 meters. So we are looking for this angle here, angle theta. Looking at this diagram, you can see that VT is opposite to theta and PT is adjacent to theta. So tan theta is equal to VT, which is opposite, divided by adjacent, which is PT. Okay, so tan theta is equal to VT is 7 meters. PT is 26.93 meters. So 7 divided by 26.93. To find theta, we are going to find tan inverse of 7 divided by 26.93. And that will give us 14.6 degrees. So it means that the angle of elevation of the top of the taller pole from P is 14.6 degrees. So once again, we have applied the trigonometric ratios to find the angle of elevation of the top of the taller pole from P, and we got 14.6 degrees. Thank you for watching this video. This is the end of the videos on trigonometry. I hope the videos were very helpful to you. Don't forget to like and subscribe to this channel for more videos on the SHS core mathematics topics. Pick more examples and try your hands on them. If you have any problem solving any of the questions that you try your hands on, don't hesitate to interact with me on my social media handles, and I'll help you to solve the questions. Bye-bye.